Hi everyone, as I've been creating more YouTube videos, I've come to realize how much space video footage tends to take up, especially when you record in 4K. I'm definitely a data hoarder, as I'm sure many of you guys might be as well, but typical local solutions are prone to data corruption or hardware failure, and cloud solutions are extremely expensive and result in long upload and download times to store and fetch your data. That's why I wanted a system that allows me to store my data locally, but also is slightly more reliable than a singular hard drive, which might fail in a couple of years, costing me all of my data. That's why today, I'll be creating a NAS, or a Network Attached Storage. It's essentially a place where I can store all of my files and have any device on my local network access them, including my desktop, laptop, or even my phone. I plan on storing my video footage, other files, and full system backups of my gaming PC on my NAS. So, let's dive into the parts we'll be using today. At the heart of the NAS is the Zimaboard, which is a single board computer that's based on the x86 architecture. Think of it as a much more powerful Raspberry Pi. I have the 832 variant, which has an Intel Celeron N3450, 8GB of RAM, and 32GB of onboard eMMC storage. What I love about this board is its I/O. It has 2 gigabit LAN ports and a 4x PCIe 2.0 slot, both of which we'll be using today. For the storage, I have three 4TB Western Digital NAS hard drives that will be stored in this hard drive cage from one of my old PC cases. To connect the drives to the Zimaboard, we'll be using this PCIe to SATA connector. It has 6 SATA ports, allowing for future expandability. Powering all of the drives will be this Pico PSU that's rated for 160 watts, which should be way more power than what we need. I also have this 240GB SSD that we'll be using as our main drive that holds the operating system, just because the onboard eMMC storage of the Zimaboard is pretty small and slow. For our VMs, we'll definitely need more than 32GB of space, along with space to store the ISO files that we'll be downloading. So let's get to building this thing. Yeah, it looks like a mess with all of the cables, but I didn't want to buy a PC case to store all of these in. I also had to use this jumper cable for the Pico PSU because we don't have a motherboard that tells it when to turn on. The build process is simply connecting the drives to power from the Pico PSU and to the PCIe to SATA board with some SATA cables. Okay, so this is the game plan for today. I want to install Proxmox on the Zimaboard, which is a Type 1 hypervisor. Essentially, it's a piece of software that allows us to run multiple operating systems at the same time by splitting up or virtualizing the hardware. It introduces extremely minimal performance overhead when compared to running the operating systems on bare metal. I used Rufus to flash the Proxmox ISO on this flash drive, which we'll need for the installation process. I want two virtual machines running in Proxmox. The first is for the NAS operating system, for which I plan on using TrueNAS Core. For the second virtual machine, I want to run Windows. We'll talk about some additional details about TrueNAS Core and my design decisions after we get things set up. For the Proxmox install, we need our Zimaboard plugged into a monitor, along with a keyboard, mouse, and the flash drive so we can set up Proxmox. After plugging the Zimaboard into power, we need to boot into the BIOS to change a couple settings. For the Zimaboard BIOS, I had to repeatedly press the delete key on the connected keyboard. First, I ensure that Intel virtualization and VTD are enabled, which are mandatory for running virtual machines with a hypervisor such as Proxmox. Finally, I set the boot order such that the partitions of the flash drive with Proxmox are at the top. I then save and exit. Then the Zimaboard boots into the Proxmox installation screen. Make sure that there's an Ethernet cable plugged in because the Proxmox installation needs it. The installation steps are pretty straightforward. I choose the 240GB SSD as my installation disk. I also add 8GB of swap space that our machine can use as extra RAM if needed. After choosing the country, time zone, and keyboard layout, I enter a password and my email followed by a host name. Then the installation begins. If you're installing Proxmox onto an eMMC disk, there are some extra steps that you need to follow, which can be found at this website, which will be linked down below. The device will then reboot and you'll see a screen that contains the IP address of the Proxmox server's web interface. You can visit this IP address at the port 8006 from any device on your local network. After visiting that IP address, we'll get a certificate authority invalid screen. This is okay. We can still trust the website because it's hosted by us. After logging in with the root user and the password we set during installation, we'll start off by installing our NAS operating system, TrueNAS Core. This is an operating system that provides a one-stop shop for managing storage devices such as our hard drives. We want the devices on our network to see these 3 hard drives as just one giant storage pool, which will make it easier to use. TrueNAS uses the OpenZFS file system, which provides many useful features such as data integrity checks, snapshots and clones, and support for redundancy. This last bit is especially useful because hard drives are known to fail occasionally. Our storage pool will be structured such that any one of these three drives can fail and we will not lose any data. In exchange for this redundancy, we give up the storage capacity of one of the drives, resulting in a final pool of only 8 usable terabytes rather than 12. If a drive were to fail, however, we can simply replace it, and TrueNAS will rebuild our array, and then we can continue using the storage as if nothing happened. So to install TrueNAS, we first have to download the TrueNAS ISO to a storage pool on our SSD. We then give it the URL to the TrueNAS ISO so Proxmox can download it. Now comes the fun part. Let's create our first virtual machine. To create a new VM, we right-click on our node on the left side of the screen and click Create VM. We set the name of our VM and choose the TrueNAS ISO. We go with the default 32GB drive that we'll use to install the TrueNAS operating system on. For the resources we want to allocate to the TrueNAS VM, we choose 2 cores and 8GB of RAM. Before we start the VM, we quickly add a 80GB drive that will be used as a cache for our storage pool in TrueNAS. I've read in some places that this might speed up accessing files stored in the pool, so I just wanted to try it. Then we have to pass through the 3 hard drives attached to our Zimaboard to this virtual machine, so TrueNAS can have complete control over them. I SSH'd into Proxmox from my local terminal and then ran these 3 commands to pass the drives through. They use the ID of the TrueNAS VM and the serial numbers of the hard drives to uniquely identify each of them. A direct result of virtualization is that the operating system in the virtual machine does not know it's inside of a virtual machine. So TrueNAS will now think that these drives are plugged in directly to the machine it's running on. We can start the VM and begin the TrueNAS installation process. I'm not going to go through the exact steps because they're pretty self-explanatory, but I choose the 32GB drive as the destination media that will hold the operating system. Then I type in a secure password and select boot via BIOS. If I choose UEFI, the installation process will fail. After the long installation process, we see another IP address that we can visit from any device on our local network. This allows us to access the TrueNAS web interface. After navigating to it in our web browser, we log in with the root username and the password that we selected during the TrueNAS installation. We're greeted with the TrueNAS dashboard. The first step is to create a storage pool with our 3 hard drives that we passed through, plus a cache with the 80GB drive that we created. TrueNAS defaults to using RAID Z, which means we can have one drive fail and not lose any data. It gives us our estimated raw capacity at 7.27 terabytes, which is around what we expected. I just ignore the warning about our 80GB drive not having a serial number because we won't actually be storing any data on it, and then I set it as our cache drive. We finally name our pool and then hit create. After we create a pool, we have to create a dataset, which is what we'll actually be sharing on our network for other devices to store files in. I name it NAS and leave all of the other options alone. Next, I quickly create a user that'll be used to access our NAS across the network. Now we create our SMB share. This is a network file sharing protocol used mainly by Windows machines, but is also supported by other operating systems. It's what allows for other devices on my home network to connect to the NAS. We choose the path of our dataset as our location and then configure the permissions such that our source user can access it. Let's now test our NAS. I open up a File Explorer window on my local Windows machine and click Add a Network Location. I use the IP address of our TrueNAS installation and the name of our SMB share, which defaulted to the same name as our dataset. After clicking Finish, we see the storage pool pop up with the right storage size. For all intents and purposes, this is just any other folder on our computer. We can copy any file we want to it. Just for fun, I copy over some drone footage that I had lying around on my computer, totaling at about a gigabyte in size. It looks like we're almost saturating our 1 gigabit connection to the NAS, which is a good sign. I hope to later upgrade my home network to a 2.5 or 10 gigabit connection in the future, but for my current needs, these speeds should be fine. It looks like the file copy was a success. This file is now officially living on our NAS. We did it, guys. There's just one small problem. All of the data on this NAS is still local. While I'm protected against one hard drive failure, due to the redundancy, I'm not protected if more than one drive fails, in which case all of my data is lost. A prime time for this to happen is when I'm rebuilding the array, because during that process, I don't have any redundancy. I'm also not protected against any mistakes I might make regarding my files, such as accidental deletions or corruption due to a virus. I'm also not protected against my apartment burning down or getting broken into. This is the key difference between redundancy and backups. Redundancy can protect against hardware failures, but backups protect against things that redundancy cannot cover. This is why I mentioned earlier that I wanted two virtual machines. The second one will be a Windows VM that backs up the data from the NAS and uploads it to BackBlaze, a relatively cheap cloud solution with an annual fee of only $99 for unlimited storage. There's just one small problem. BackBlaze's unlimited storage computer backup feature does not support Unix-based OSs, nor does it support NASs. This means we need a slightly unorthodox workaround, hence the Windows VM. We need one more piece of hardware with the VM, this 12TB hard drive inside of this USB 3 enclosure. The plan is to schedule a backup that copies over all of the data from my NAS to that hard drive, which has more than enough space, and then use BackBlaze to back this hard drive up to the cloud, which is allowed because it'll be directly connected to our Windows VM via USB. The reason I'm not using SATA for this drive is because I want to be able to easily unplug it from the Zimaboard and use it elsewhere if necessary. BackBlaze allows backing up drives that are connected directly to the computer, which is why we want this drive to be connected to the VM. Another way to think about this setup is that the TrueNAS half protects our data by providing redundancy, and the second half, with Windows and BackBlaze, will protect our data by providing offsite backups. This will result in me having 3 copies of my data, one on my NAS, one on this hard drive, and one in BackBlaze's servers. 2 of them are local and the third is off-site. This was the simplest solution I could come up with, while avoiding other complicated options like setting up NFS or rsync in FreeBSD. If you think you have a better solution that's similar in price, let me know down in the comments below. So now let's set up our Windows 10 VM. I've already uploaded the Windows ISO after creating it with Microsoft's Installation Media Creation tool. And for Windows specifically in virtualization environments, we also need some special drivers, which are present in the virt.io ISO file. The process of creating the Windows VM is very similar to the TrueNAS VM, except we choose Windows as the guest OS and select the additional ISO file for the virt.io drivers. We again go with the default 32GB disk and set the number of cores to 2 and the RAM to 4GB this time. Yes, our 2 virtual machines use up a total of 12GB of RAM, which is more than the Zimaboard has, but that's why we added the 8GB swap when installing Proxmox. I'm sure many of you guys are familiar with the Windows installation process, so I'll speed through that here. The only thing to note is that in order to see the 32GB installation drive, I had to install the SCSI pass-through controller driver from the virt.io ISO. After booting into the operating system, I installed the missing drivers by going into the device manager and simply having Windows look for the appropriate drivers in the virt.io ISO. We now need to make sure the VM recognizes our drive in the USB enclosure. I first plug in the drive into my main Windows desktop, the one that's not virtualized, and format it with the NTFS file system. Then I plug it into the Zimaboard and pass it through to the Windows VM in the Proxmox UI. We now see the hard drive pop up in the VM. I quickly change the name of the drive to NAS Backup. I then download the BackBlaze exe file and install it in the VM. It's a very simple process and it starts backing up my C drive and my F drive, which is the 12TB NAS backup drive, as soon as the installation finishes. Finally, we need a way for the data on my NAS to be copied onto the backup drive, for which we use a piece of software called Aomi Backupper. There's a free version that should cover my use case, which is convenient. After installing it, I connect the Windows VM to the NAS network share using the same process as I used on my Windows desktop. Then, in Aomi Backupper, I schedule a basic sync task that simply copies over all of the contents from the NAS network share to the local NAS backup drive every night at 3 AM. We see the source.mp4 file that I copied over previously is now also on the NAS backup drive. Now, the backup solution is finally complete. This is how I plan on using this system. Step 1. I copy over files from any device on my network to the NAS network share hosted by TrueNAS. Another use case is creating full system images of my Windows desktop that'll be saved directly to the NAS. That way, if anything goes wrong on my desktop, I can easily revert to an older version without having to reinstall Windows from scratch. A final use case is for when I'm recording my A-roll for YouTube videos. I usually do this on my laptop that has my camera attached to it via a capture card. This way, I should be able to directly record my footage onto my NAS and then immediately access the files on my desktop, which I use for editing. Step 2. Every night at 3 a.m., a Yomi backupper will copy over the files from the NAS to the NAS backup drive. Step 3. BackBlaze will then sync the NAS backup drive to the cloud. But hopefully I now have enough storage for all of the future YouTube videos that I'm really excited to create for you guys. If you plan on replicating this setup for yourself or have any questions about any specifics, please let me know down in the comments below. In the meantime though, thank you so much for watching and I'll see you guys next time.